Hey everybody, Mike here from GeoEngaged with another GIS tutorial. Today I'm going to be talking about the fit2gpx custom Python module to transfer files from a fitness app, put them in GIS software, and visualize them. The inspiration for this tutorial, I had a friend of mine ask if he could take elevation data from his fitness app and put it in GIS. And I said, I'm pretty sure that's possible, but let me dig into it. Then I did, and I actually wanted to visualize my lap information, not just my elevation information. And I discovered that that information did not get carried over from the GPX file. But I did find another file that's a .fit file that had my lap information, and I was able to find this custom fit2gpx Python module and combine it with Pandas data frame, and some ArcGIS features, the geo accessor and geo series accessor, to add the lap information over. So before I get started in ArcGIS Pro, I'll go ahead and show you that GitHub page for fit2gpx. This is a simple Python library for converting fit files to GPX files. This one talks about Strava. I actually am using the files from my Suunto watch, so it's pretty universal. I already have a notebook prepared, but in the event that you need to make a new one, and you're in your default map that ArcGIS Pro opens, you can open a new notebook by going to this Analysis tab in the Geoprocessing section, go to Python Notebook, and it'll open a new one. So first things first, I need to create a file geodatabase to house my data in. You'll see over in this section here, I have a geodatabase here already, but I'm going to make a different one. And additionally, some important files later on are this Symbology file and this fit file. The fit file is the file that I have taken from my Suunto app and put in Windows File Explorer to do this tutorial. So I have put some comments in here to kind of guide the tutorial, create a file geodatabase to house data in, and then the ArcPy function that we're going to use. And last background check before we start doing the tutorial. This syntax here I've taken straight from the Esri documentation. So if I show you that, create file geodatabase, data management, and here's that syntax. I've done that for all of the ArcPy functions. So if you want to reference this on your own, just reference the Esri documentation. So we'll go ahead and start by creating our file geodatabase, and I want to put it in this folder here. I can right click that and copy as path, put that right here as my first parameter, and I'm going to want to put that in quotes, and also going to want to make these backslashes forward slashes. That's just one way to do it, but the single backslash that is there by default, Python can have issues reading that for reasons. And I'm actually going to name this database tutorial. And you see this tutorial database is not in there currently. When I hit run, we're successful, and now you see this tutorial database is there in the catalog window. Nothing's in it. So now that we have our file geodatabase, let's go ahead and import our packages. So we're going to import Pandas SPD. we're going to import from the ArcGIS features module, the GeoAccessor and the GeoSeries accessor. And then from fit2gpx, import converter. And we'll use this converter. We'll go ahead and make a variable for it, conv to shorten it up. And that's just going to be the converter function. And then we're going to have a series of file locations. To start, I'll make a fit file variable. And again, in here, catalog window, I can right click and copy as path. Place that in there, put this in quotes. Change these backslashes to forward slashes. Now, throughout the tutorial, I could manually type in this file path for every time we're going to use it, but instead I'll define these variables up front and use them. So that's an example of how you can copy and paste a file path from the catalog window. And I have some other file paths here prepared. I'll just go ahead and copy and paste these over. But these will be unique based on what you're doing. So let's go ahead and run that. And we're successful. And one other note here, Jupyter Notebooks is nice because you can run the code line by line to make sure that it's working as you go. That's one nice thing about it. The next thing we're going to do is create a Pandas data frame from the fit file. So we'll use this fname variable here, or parameter rather, and we'll use our fit file variable we defined earlier. So let's run that and see if it works. Perfect. And then we can test to make sure that's working using the head function from Pandas. So we'll use our data frame point dot head, and this will display the first 5 rows of our data. And just a note for future, this lap column will be important. Also to note, there is no object ID column. We're going to need an object ID column to join with the ArcGIS feature class. So we'll go ahead and insert that. So data frame underscore point, insert, use our location of 0. We'll name this object ID, the column. For our value, we'll use this range here that I have actually gotten from some research online. Let's go ahead and test and see if that works. And we'll go ahead and run the head function again to see the difference. So we have our same information here, but we have an object ID column. So now we're going to move on to converting that fit file to a GPX file using the fit2gpx Python or ArcPy function. You can reference online, but our source file is going to be our fit file variable that we defined earlier, and then our out file is going to be our GPX file variable. We'll go ahead and run that. This error message has been popping up. I'm not quite sure what it means. If you know, go ahead and let me know in the description. We can carry through with this process nonetheless. And the GPX file won't show in the catalog window, but if I go over to my file explorer, you can see that it's located right here. So we have successfully created that. And then we will convert that GPX file to a point feature class. Using the GPX.features ArcPy function. So we'll use our GPX file. We'll go ahead and use our video tutorial points variable as our output location. But just for reference, this is the file path for that. Fit, doesn't mess with me when I try to highlight it. There we go. And we don't need the optional parameter of output type, so let's run that. And you'll see it'll populate in the map here. Right there. And if I toggle over to the map, you'll see we have some points on here. Now we want to do some refining to this. But I'll go ahead and show you in the attribute table. We just have our elevation data here, but not our lap data. By the end of this, we'll have a lap column here. So let me go ahead and open that back up actually and dock it down here. Just drag and drop it. And you'll see after we use this join field ArcPy function that the lap information will be there. And our join table. Object ID. So that's our object ID column. Oops, apologies. Let's go back to where we mean to be here on the join field. Our join field, or our in field rather, is going to be the object ID column. And our join table is going to be our data frame points. And we're going to join that on the object ID column we created earlier. And we're going to join that with the laps. Make sure I write this correctly. And if this runs successfully, we'll see the lap get populated here in the attribute table. It's data frame point, not data frame points. And perfect, you see the attribute table now has the lap column. We scroll down, we have 5 laps in this data set, so we're going to use that to our advantage to symbolize this later. So I'll go ahead and close that, and then I want to convert these points to lines because it'll look a lot neater in the map. So our input features are the video tutorial points. Our output feature class is going to be the video tutorial lines variable we defined here. So this is create a line feature class in the FileGeo database we created earlier. And then we will symbolize this line field or categorize this line field by the lap field that we just added using our Pandas data frame and join field functions. So let's run this. And a line feature class will generate. If we toggle back to our map and put this line's on top, turn these points off, so we have lines. And just as a bonus here, I I have a layer file that I'm going to apply some symbology to this. So it's going to be arcpy.management, apply symbology from layer. Our in layer is going to be the video tutorial point lines feature class. And then our in symbology layer is going to be our lap symbology.lyrx that I've defined in the variable here. Let's go ahead and copy and paste this variable here. Won't let me. And we'll need to go ahead and tell it to symbolize based off the value filled lap. So when I run this, the symbology will be applied for me automatically. And there you have it. So in this tutorial, we've taken a fit file from a fitness app, used fit2gpx to convert that fit file to a GPX file, then used Pandas data frame to join some information that isn't in the GPX file by default. Then we brought that information converted that GPX file into a point feature class, converted it to a line feature class, and then applied some symbology to it. So I'll have a article on the GeoEngage blog about this that's more of a storytelling format. I'll go ahead and link that in the description below, along with links to all the resources that I've used to make this happen. So appreciate your time. I enjoyed spending it with you, and look forward to hearing what you think about it. Thanks.